Hello, this is Ryan, and I'm going to go over the bolt strength analysis tool that I have on my portfolio website. As a mechanical engineer, I did bolt analysis, which is pretty difficult to do because the software doesn't just tell you whether the bolt's strong enough or not. You have to usually take numbers from the analysis and then run it through a bunch of equations in order to determine if the bolt's strong enough or not. So I created a spreadsheet that kind of gathered up all the different bolt analyses that were being done at the time and turned it into one tool that you can just put in one set of parameters and it would give you all the values back. So let's take a little bit more of an in-depth look at it. So I actually have instructions for how to use the tool, and it'll explain all the different inputs that you have, the geometry parameters with images that kind of show you how to use it, and it'll explain this in pretty good depth how to use the tool. But if you're not a mechanical engineer and you're not doing bolt analysis, it's probably going to be confusing, but it's meant for people that know what they're doing. So I'm just going to run through and show what the analysis will look like. So first you'll have two plates that are bolted together. So we need the information for the plates. So let's just assume that they're going to be half-inch bar. So I'm just going to pick that material, aluminum bar. I'm going to say 0.5. I'm going to do the same thing for this one, zero point 0.5. We're going to pick a grade 8 bolt. That's a kind of common bolt, so we're going to use a grade 8 steel bolt. And we're going to say that it's 3/8 24 2A. It's just a common bolt. Grade 8 on the nut as well. And then we have our forces and moments, which the FEA software, which is finite element analysis, will return back to us for the bolt based on the loading that you put onto the plates. So let's just assume it's 1000, and we'll just say the rest of these are 300 for the rest of the forces and moments. And we'll say that the minimum edge distance is 1 for each way. So that's how far the center of the bolt is to the edge of the plate that it's bolted to. And then we'll also say that the constraint distances are the same for the other ones. And then we'll say that the nut, let's just assume that it's also 3/8 of an inch point thick. And then we'll also put in our 3 and 5 factors of safety, which are pretty standard values in like the aeronautical industry. So once we have all the parameters set, you can hit calculate and it'll tell you all your inputs that you just did, and it'll start going through and showing you the variable and the equation for the variable and the value that it returns for all the different calculations that it does. So for the nut and bolt, it does all these area calculations and then it combines the forces and then gives you the stresses, which stress is force over area. So that's why we look at stress, and there's different kinds of stress to look at. So I have all the different kinds that apply, and I also find the maximum loading you can put on the nut and the bolt before you start stripping the threads. It also does all these same calculations for the two different plates on how much stress there is on the plate and if the plate's going to get damaged. Then once it goes through and does all those calculations, it looks at our factors versus the material properties that kind of are programmed in the background, and it'll spit out the margins of safety that you have. Anything above 0 means that the bolt is strong enough. So it looks like based on the analysis we just did, all these the bolts and the plates are strong enough for the loading that we put on them. And that's all the tool does. I mean, it's pretty complex overall, but if you know how to get the values from the software and put them into here, it makes your bolt analysis really easy, and it's more comprehensive than what I saw the tools I was using when I was in the field. So thank you for watching and have a great day.